Geometry Test 11, and I'm going to relate this with your book so you can see a lot of these questions are just right from your book. So let's start. The first is true, false. So we have to think, if it's true, it's always true. If it's false, it's always false in this test here. So the first statement says, number 1, regular polygons of the same number of sides are similar. So on page 264, let's turn to 264 there so I can show you where it says it here. The theorem, it says regular polygons of the same number of sides are similar, right out of your book. So that's true. On to the next, number 2. An apothem of a regular polygon is the radius of the circumscribed circle. It's on page 263. That's a tricky one because it is the radius, but it's not the circumcised, it's going to be the inscribed. And that's on page 263. The definition's on page 263. Let's look at it. The apothem of a regular polygon is the radius of the inscribed circle, not the outside circle. So that inside, just remember, apothem means in. Apothem. So apothem is inscribed. So let's make that one false. Remember I told you when we went over it that you had to know that it's always the inscribed, not the circumcised. Remember the inscribed, basically the inscribed is going to be, if you have a polygon, if you have a polygon inside, that would be circumcised. So here's a B. Let's just do a square in here. So here we have the inside, and then inside circle will be inside this, so it's going to be the inside circle. That's a terrible picture, but I didn't have my compass. On to number 3. The area of a regular polygon is equal to the product of its perimeter and its apothem. Sounds good, doesn't it? But that is not the equation. Remember I said it's going to be a product of the perimeter and its apothem, and you have to have 1/2 of that. So let's look on page 266. So here it is. The area is 1/2 the apothem times perimeter. The area of a regular polygon is equal to 1/2 the product of the perimeter. Not just times them, you have to half them. So it's 1/2. So this would be, it doesn't say anything about 1/2. The area of a regular polygon is equal to the product of its perimeter and apothem. It's 1/2 of that. So 1/2, number 3. These are kind of in your book. If you go over, just to remember, okay, you look right there. Oh, forgot to half it. So number 4, a radius of a regular polygon bisects the vertex angle of the polygon. Yeah, so here's a regular polygon, a triangle that's in a circle, and the radius goes there, bisects the vertices, right? The radiuses do. So that'd be true. Page 216, number 8, or 263, say 263, number 8 says, the radius drawn to the vertex of the regular polygon bisects the angle. They have these little ones that are kind of hidden. So when you're reading this and going through your book, you always have to look at these small ones. So the angle of the regular polygon is equal to the supplement, this is the radius drawn to the vertex of a polygon bisects. So it does. That was pretty easy to see anyway. Number 5, as the number of sides of a regular polygon inscribed in a circle increases, the length of the apothem of the polygon decreases. So on page 268, I don't know if we went over that, but on page 268 is this picture, remember? So this picture has it, here we have 4 sides, and here's the apothem. And then if you have more sides, this way, depending on how many sides you have. This is the apothem this way. So let's see. So if I put, basically, the apothem of the size of the apothem is going to get closer and closer. As you get more sides, it's getting closer and closer to the circumference. So the apothem is not going to decrease, it's going to increase. So this decrease is wrong. So as you get closer and closer to the circle, the apothem is going to increase. See how it's increasing there with that apothem? So that answer is going to be false, right? On to number 6. If the radius of a circle is 2 inches and the number of square inches in the area of the circle is the same number as the number of inches in the circumference. So what are they asking here? So they're going to say if you have a radius circle that's 2 inches, then the number of square inches in the area of the circle is going to be the same number as the inches in the circumference. So you have to figure this out. This is page 267, number 83. It's not page 267, it's going to be two. Let's see. Oh, 83 here. It's on 269 actually. And it's on 270 actually. 270. The area of the circle is equal to 1/2 the product of the circumference. So we need to know that. The area of a circle is going to equal 1/2 the product of its circumference and its radius. So remember this, area equals 1/2 circumference and radius. So here we have, we're going to take 1/2 circumference. Here's the big C means circumference times the radius. So it's going to be 1/2 circumference, and what's the radius? 2. So we fill in 2. So this is pretty easy here. So we have 1/2 2. So look at, so if it's when you figure this out, what's 1/2 2? 1/2 of 2 is 1. So this is going to be 1. So the area is the circumference. So it's true. So basically figuring that out, you find out, yeah, it is the circumference. Because if you times this by 2, you're going to get rid of that 1/2, and then basically the area is going to be just the circumference left. We got rid of the 2 on this side and the 1/2 on this side, and we just have the circumference left. So this is true. On to number 7. If the length of the radius of a circle is multiplied by the positive number s, the circumference of the circle is multiplied by the square of s. So first of all, let's look. The length of the radius of the circle is multiplied by positive numbers. The circumference of the circle is multiplied by s squared. Looking at that just like that, I would say it's false right away, because it doesn't say anything about area in here at all, you know? So here's our equation with the circumference. Circumference equals pi r squared. So, circumference equals 2 pi r. See, I goofed up. Oh, I guess I put it there, is that 2 pi r. Circumference doesn't equal 2 pi r squared. So that's not the circumference. So circumference equals what? What did we just find? The circumference equals what? So the length of the radius of a circle is multiplied by positive numbers. The circumference of the circle is multiplied by S2. So the area is not the circumference, okay? So it would be false. Area is going to be what? Area equals, let's put area equals pi r squared for area. So there's no square there multiplied by, because they're saying, is it going to, the circumference? That's not going to be the circumference. The circumference is going to be, it's not the same equation, you know, so. The circumference is going to be here. circumference equals 2 pi r. Right there. Has nothing to do with the square. I put that in there. Kind of, I guess. Okay, go on to number 8. We'll have to do this in this quiz or this test in 2 sections, it looks like, but we'll do all of the true and false and multiple choice, and then we'll go on to the equation numbers. But we don't even have a construction to do. That's pretty good. So anyway, number 8, as the number of sides of a regular polygon increases, the number of degrees in the central angles of those polygon increase also. So the number of sides, increases, then are we going to have the number of degrees increasing? So if you have 360 divided by 3, you only have 3 sides, that equals 180 degrees. So now we're going to increase the sides, 360 by 6 sides, you're going to have 60 degrees. So the more sides you have, the angles are going to get smaller, aren't they? The center angles are going to get smaller. So it's going to decrease. So this answer has to be false. So as you get more, those are pretty big, 180, but say you get So these basically the central angles, the number of degrees, these degrees are going to get smaller, right? So we're talking about these degrees, the central angles. So the number of sides of the polygon increase, the number of degrees in the central angles are going to decrease, not increase. Number 9, the ratio of the circumference of a circle to its diameter is constant. Yay! Yes! The ratio of the circumference of a circle to its diameter is always constant, and this is always pi. This is the ratio of the circumference to its diameter. The circumference of a round, ratio to its diameter, this would be the diameter that goes through. That ratio is always constant in the circles, and this number is pi. Yes, true. Number 9 is true. Number 10. Make sure you don't get these mixed up either, too. Kind of putting these don't get the answers mixed up. I'm kind of putting them like that so you can see. Let me write these here because I don't want you to get the wrong answers as we go through, okay? So we are on number 10. An equilateral polygon is a regular polygon and it must be equilateral. Well, for one thing, an equilateral polygon is a regular polygon, but it must be equilateral and equal angular. Because look, we have one here, we have a rhombus. This has 1, 2, 3, 4 sides that are equilateral. But is this a regular one? No. Can you put this in a circle? No. You only can put a square in a circle, right? Like this. It wouldn't go in a circle. So basically, this would have to be false. It has to be both equilateral and equal angular. Equilateral and equal angular. Oh, I wrote it there. I'm sorry. I already wrote it. Equal angular. Equilateral and equal angular. Kind of hard to say. Number 11. A regular polygon is equal angular. Yes. A regular polygon is equal angular. So this one, number 10 would be false, and this would be true. A regular polygon is equal angular. We just answered it in that question. Number 12. Equal angular polygon inscribed in a circle is regular. What would we just say? It has to be equilateral. So let's look on page 76 or page 260, 76. It says right in the book, An equilateral polygon inscribed in a circle is regular. And this one says equal angular. Tricky. So equilateral is in a polygon inscribed in a circle makes it regular. That means all the sides have to be equal length, right? So this would be false. Number 12. Number 13. A circle can be circumscribed about any regular polygon. That's pretty easy. True. If you have a regular polygon, you could put a circle in it, right? Or put a circle around it. Circumscribed means around it. So any regular, if this was regular, all the sides being the same, you could always put a circle around it. It can be circumscribed. So true. Number 14. The ratio of areas of two circles that are not equal is the same as the ratio of the lengths of the radii of the two circles. So the ratios, we're talking about ratios. So the ratios of that are two areas. So basically it's basically saying, this is what it's saying. It says you have an area and you have an area, it's going to equal the radii. This is the area of 1, this is the area of 2, this is the radii of 1, this is the radii of 2. This is not, because guess what? We're dealing with area. You have to square them. So the area of one circle and another circle, they both have to be, their proportions have to be squared. So the area of the radius of the first one, the radius have to be squared. So this would be false. There's nothing to do with square in there. Whenever you have areas, you have to be squared. Okay. The next one says, if a circle is divided into 3 or more arcs, the chords of these arcs form a regular polygon. So you divide it in three. You have divided into 3 or more arcs, and the chords. So here's some arcs. So you divide it. Of course, this one's regular. So we have 1, 2, 3 arcs, and that's regular. But what if we had a chord here and a chord here and a chord here? That surely wouldn't be regular, right? You must have equal sides. We just have that up here. An equal lateral polygon, or where is it? A regular polygon is equal angular, equal lateral. Actually, where was the one where we have? Basically, an equal lateral polygon is a regular polygon, with the equal angles and equal sides. So, and this one is the question. An equal angular polygon, remember we said it's equal lateral. It has to be equal lateral. All the sides have to be equal. So this is nothing about equal sides or equal angles. It just says sticking chords across it, right? So this one's false. You must have equal sides to be equal lateral to be regular. So you must have equal sides, you must be equal lateral. And this isn't, so false. Okay, now let's do some of the multiple choice with number 16. So we're just going to go up to number 20, and then we're going to do the others on the other test. I don't think we'll get to the end of the test on this one. We might. A regular decagon, what's a decagon? Has 10 sides. It's regular, so its sides are regular. Has a side whose length is represented by S. That's the side of it. And the apothem, whose length is represented by A, meaning apothem. The area is represented by what? So this is kind of tricky. Let's turn to page 266 in Theorem 81. It says, what does it say here? It says, the area of a regular polygon is equal to 1/2 the product of its perimeter. So here we have the area equals 1/2 apothem times perimeter. Remember we said that before? That was one of our true-false questions. And so the area is represented here. I put down as the area is 1/2 perimeter times apothem. So we have 10 sides, right? We have 1/2, 10 sides. 10 sides, what would be, well, when you think of perimeter, basically being 10-sided, the 10 sides, you're going to, you know, basically going to be 10 times the side, right? 10 times the side times the apothem, right? So here's 10 sides. So let's change this here. We have 10 sides times the apothem, because there's going to be 10 sides. 1/2 10 sides times the apothem. So now we have 1/2 of 10 is what? So it's going to be 5 times the apothem times the side. So it's going to be 5 apothem times the side is going to equal K. It means the area. Just remember that's what they use, the letter they use for area. So it's going to be 5 times apothem times size, because it's going to be 1/2. If you look in this here and you know it's going to be 1/2, you're just going to divide it by 1/2. 10 by 1/2 is 5. So you know it's going to have to be 5 times apothem. So it's going to be C. So 1/2, you take 1/2 of 10 times the apothem. So 5 times the apothem times the side. For some reason I didn't put the side in there. There we go. Number 17. As the length of the radius of a circle increases, the ratio of the circumference to the diameter of the circle, what? So the ratio of the circumference to the diameter, you know, so is this going to change? So what is the ratio of the circumference to the diameter? You remember? This is our big thing. The ratio of the circumference to the diameter is pi, for goodness sakes. It's always constant. So the ratio of the circumference to the diameter is pi. So it's pi is always constant. So constant. Remember that pi is the ratio of the circumference to the diameter. Pi. It's always the same. Number 18. If the length of the radius of a circle is multiplied by 4, then the area of the circle is multiplied by what? By square, right? Because we have area, we're always going to square it. So if it's multiplied, if the length of the radius of a circle is multiplied by 4, the radius is going to be multiplied by 16, right? Because you're going to square 4. So 4 squared equals 16. Oh, look, there's 2, 4, 8. So it's going to be none of these because it's 16. You can put 16 in there. Number 19. For some reason, I have this one circled. I don't know why. So let's see. Essential angle of a regular polygon and vertex angle of that polygon are never what? The central angle and the vertex angle are never equal. So if we have this is the central angle. Let's just we're going to do like that. This is the central angle. Like here's the central angle. And the vertex angle are going to be this angle, this angle. They're never equal. So they're never, it says never supplementary. Yes, they are. They are actually supplementary. So that'd be, this is a tricky one. You can, that's why I circled, because it's tricky, because it says the central angle of a regular vertex angle of that polygon are never supplementary. They're always supplementary. So that would make it false. And so, but anyway, they're never equal. They're also, I don't think, ever complementary. So this is kind of a trick question. That's why I railed it, because they're never equal, but they're never, wonder if they could be equal if they were 90 degrees. Let's put down they're never complementary would be what? Well, they're never complementary. So you can put down this one or this one, whichever one you want, and we'll see which one we get right. So number 20. But they're supplementary all the time. Let's not put the equal. Let's put down complementary. Never complementary. So number 20. The area of a circle with a diameter whose length is represented by D, is the diameter, is represented by, oh, do you remember? We have that. It's on page 271. I told you, remember this. Equation. Okay, right here at this corollary at the top. The area of any circle is expressed by the formula. Either it's going to be pi r squared or 1/4 pi times d squared. Remember, we had to square that 1/2. Because when you think of taking 1/2 off, you got to take not a 1/2, but 1/4 out. So A is 1/4 pi d squared. Okay, let's see. I don't think I'll be able to finish this up. So we only have 10 more questions, but we have a long one in the midst. So let's stop there, and I'm going to finish up the test in the next.